Hello all, today in this video I'm going to share a demo video for email spam detection. Already with this same data set we have worked with some other machine learning algorithms. In this video we are going to work with the gradient boost algorithm and going to make some comparison with the other machine learning algorithms we have done so far. So for that initially I'm just importing the libraries which are needed, and then importing our data set. This data set I downloaded from Kaggle. If you just give like email spam detection data set Kaggle means, you will just get the link. It is having nearly 3002 entries. Among this the first 3001 entries we are going to use as the X data set, X variable, and the last prediction variable here we are going to use as the Y variable. And then we are getting the info of this data. From this we are getting to know already. If you see means, mostly everything was integer values when compared to email number. It is only having some string. So you can just notice that here it is given that one is object, that is this one, every others are integers only. Next, we are just checking whether the data set is having any null entries. It is not having any null entry, so we are just moving to the determination of X value and Y value. By using this X value and Y value, and by using the train test split function with the test size as 0.25, we are determining X train, X test, Y train and Y test value by using the test size as 0.25. That is 25% is taken for testing, and the remaining 75% is taken for training. So already we have worked with the random forest algorithm, and we have got an training accuracy of 100 and testing accuracy of 0.9737, and we have also plot an ROC curve for every algorithm. So by using the false positive rate FPR and true positive rate TPR at the y-axis. Then we have worked with the support vector mission, and we have got an training accuracy of 0.8092 and testing accuracy of 0.7710. For this also we have plotted an ROC curve. Then we have worked with the Nebase, and we have got an training accuracy of 0.9646 and testing accuracy of 0.9590. Then we have plotted an ROC curve. Then we have worked with the KNN and got an training accuracy of 0.9064 and testing accuracy of 0.8708, and we have also plotted an ROC curve. Then we have worked with the decision tree, and we have got an training accuracy of 100 and testing accuracy of 0.9365, and then we have plotted an ROC curve. Then we have also worked with linear logistic regression, and we have got an training accuracy of 0.9832 and testing accuracy of 0.9659, and we have plotted an ROC curve. Then we have worked with the XgBoost, and we have got an training accuracy of 100 and testing accuracy of 0.9806, and we have also plotted an ROC curve. Then we have worked with the Catboost, and we have got an training accuracy of here it will learn for different iterations, and finally at the once it is determine the best learning rate only, it will give the accuracy value. The training accuracy is 0.9997 and testing accuracy is 0.9729. Then we have plotted the ROC curve, and in this work we have worked with the gradient next we have worked with Lightgbm. Here the training accuracy is 100 and testing accuracy is 0.9837, and we have also plotted an ROC curve. Then in this work we have worked with the gradient boost, and I could have defined in every videos that the only difference with every machine learning algorithms is the library. So first we have determined or imported the library which we needed, and then we have determined the gradient boosting classifier library within an variable, and this variable we are using to determine the values of training results and testing results. All others are common only. In training we are getting the training accuracy as 0.9835 and training ROC AOC score as 0.9988. Then the testing accuracy is 0.9528 and testing ROC AUC score is 0.9948. you can notice the confusion matrix for training and testing also, and you can also notice that there is a vast difference between the numbers in training and testing. This is because we are using 75% for training and only 25% for testing. So only we have got this difference. Then we have plot an ROC curve for this gradient boosting. Then obviously, as we do for every algorithms, we have made a comparison of all the algorithms we have done so far. So we have done random forest, support vector, mission A, base, KNN, decision tree, logistic regression, XgBoost, Catboost, Lightgbm, and now within this code we have worked with the gradient boost. So all these models we have called within a variable called model, and this model we are making into a loop, and within the loop we have training the model by using the fit function, testing the model by using the predict function, and then we have determined the values like accuracy, mean square error, and R2 square error, and then we all the values of the training and testing accuracy of every models will be determined. You can see within the single cell itself. Then we are making a table comparison. In the table comparison we have made some highlight points like the model with the best accuracy will be shown with the green color, and the model with the least accuracy will be shown with the red color. You can notice that Lightgbm is the model which is having the best accuracy, so it is shown with the green color, and support vector mission is having the least accuracy and it is shown in red color. So after Lightgbm, this Catboost random forest takes the place, and after that Catboost, then comes the no. After Lightgbm, this XgBoost takes the place, then only random forest, then Catboost, then in A base, then the algorithm which we have made now, which is gradient boost, then is logistic regression. So I'm just confusing it, you can notice by your end itself. So in the next video we will be making some other demo video. So if you are interested in knowing any other demo video means, please let us know in the comment box or through mail. So if you are aware of it means, we will be definitely making video regarding it. Thank you.